Hello, everyone. Yeah, I see your greetings from the US, from Mexico. Nice to see, well, names that I already know. Welcome to our third session of IT Marathon. The procedure is absolutely the same. Please send your question during the talk to the Q&A session, to the Q&A window, and chat is for chatting, of course. Well, that's it from my side for the intro, because this is third day and I think all of you already know all this functionality. So I would like to briefly introduce our today's speaker, Wojciech, who is our guru from Poland. If I'm not mistaken, you're a cloud architect, right? And you are in Krakow.
Yes.
Yes. So today we will talk about data storage solution for Azure, and that's all I know about this topic. So I'm passing the floor to you, Wojciech.
Okay. So welcome everyone. My name is Wojciech. I'm a cloud architect from Luxoft. As mentioned, I'm based in Poland, in Krakow. So today I'll be talking about a cloud platform that is getting more and more popular, which is Azure. And specifically, I'll be talking about most popular technologies in Azure for storing and processing data. Right. So for starters, I'll briefly describe the difference between infrastructure as a service and platform as a service in the context of data storage technologies. Then I'll walk you through popular Azure offerings: storage account, data lake, Azure SQL, Azure Synapse Analytics, and CosmosDB. Since this is a very broad topic and each of these offerings deserve their own really thick book, so due to limited time, I'll focus on a high-level overview, capabilities, most important and notable features. I'm not going to give any demos or code-based walkthroughs. It would be more like an overview of available offerings and their capabilities. So that's the idea. So there are two major types of offerings in Azure. They are briefly called IaaS and PaaS. And the IaaS, which stands for Infrastructure as a Service, is a model where you basically get access to the infrastructure. So things like virtual machines, VNets, virtual networks, load balancers, get all that. And you basically configure everything as you need. That includes setting up VNet connectivity and installing and configuring all the software, all the components on your own. In this model, cloud vendor, which for Azure is Microsoft, obviously, is responsible for the availability and performance of the infrastructure. On the other hand, you as a consumer of that infrastructure are responsible for all the operating system maintenance and configuration, including patching, security, etc., middleware installation and maintenance. In case of data storage, these would be database engines and tools, and also all the operation-related activities such as monitoring, uptime, assurance, backups, disaster recovery. So to get all that right, you need to be really strong, you need to be experienced, you need to know what you're doing. The pros of this approach is that your environment is fully isolated from others, at least above hypervisor level. So Azure, the hypervisor that is responsible for running Azure VMs, and you have full control of this environment. So you can do whatever you need, whatever you want with that. but there are also some cons, like all the management overhead. You need to have people and expertise on board to effectively operate it on production, and scaling is limited usually by the size of VMs, or in some cases it's difficult to achieve at all. And in this model, the capabilities of your data platform are defined by the capabilities of Azure infrastructure you use, plus the data technology you choose. In PaaS, which stands for Platform as a Service, you just provision some platform components that are just ready to use for you. All the management and operations related aspects are covered by the cloud vendor. So you don't get to see any VMs, VNets, nothing like that. You just see the components you need. For instance, databases that are ready to connect to and use. So you can focus on your business logic and your data structures, data models, instead of running the infrastructure. And the pros of this approach are reduced and infrastructure and ops overhead, great scalability and elasticity out of the box, because these components are basically designed in that way, and they have also great integration with overall Azure platform that includes security, monitoring, automation. There are some downsides, however, of the platform as a service model, which are multi-tenancy. So your resources are usually sharing the underlying infrastructure, VMs, VNets, with other clients, with other users, which may potentially affect the performance of your systems. And sometimes it may cause some compliance issues. And the second thing is that you don't have as much control as in infrastructure as a service. You just get access to the features and settings and nothing more really. You just use what you have. For instance, you won't be able to log into a particular VM and see or copy the files. And in this presentation, we're going to focus on platform as a service offerings, because they are something that makes Azure distinct and unique from other cloud platforms. So let's discuss some of the most popular platform as a service offerings in Azure. The first one is storage account, which is one of the most common resources in Azure. It's a fundamental building block used not only by customers, but also by many other Azure, both infrastructure as a service and platform as a service offerings and resources. Typically, it's used as a general purpose, cost-effective data storage, and it comes in 4 different flavors. Blob storage, which is essentially affordable but capable file storage. Table storage, which is a very simple key value database. File storage, which is a Samba compatible file shell that can be easily mounted on some servers, on VMs. And queue storage, which is a simple but capable message queue. And for today, the maximum capacity of storage account in Azure is around 500 terabytes. So it's quite a lot. So let's take a closer look at the blob storage and table storage. Blob, which stands for binary large objects, is basically an object storage. So you just put your files there to a specific container. And there is no real file system. It's just a list set of files. In some tools that you use with storage account, you will see paths or folder structures, but it's important to know that these are not the real file system paths. They are more like virtual paths or labels. All the files, they live in one flat container. And because of that, there are some of the operations that you want to do on these files, like renaming or listing the files, is is slow. For instance, listing all the files from one virtual folder requires scanning through all the files in a container to figure out which virtual paths match. Also, renaming one folder requires renaming all the files in that folder, and that can be thousands of files. So it's not like super efficient. There are three major types of blobs for various use cases. Block blobs are files that consist of several separate segments, which makes them easy to upload or download piece by piece, or you can easily modify one specific piece. And the maximum size of single block blob is 4.75 terabytes in total. There are also page blobs, which consist of 512 byte pages, memory pages, and they are optimized for random read and write operations. And their typical use case is storage for a virtual machine images. And the maximum size of a page blob is around 8 terabytes. And there are also append blobs, which are probably the least popular, and they are commonly used for logs because they are append-only files. You can only append segments at the end of a file, and the maximum size of such a file is 195 gigabytes per blob. So that's it on the blob storage, and there's table storage. Tables in storage accounts are like tabular storage for quite structured data sets. They consist of rows and columns, just like in SQL databases, and they have a very basic querying capabilities. So you can select columns, you can filter by specific values, but there are no more advanced options like grouping or sorting, if we can call them advanced. All the data is partitioned so that each of the rows belongs to one specific partition, and it's addressed with a partition key and row key. So that's searching for particular row, like accessing it when you have partition key and row key is super quick. You don't need to scan through all the partitions. You just go to the one particular partition where the row belongs. There are also some basic transaction capabilities only in scope of one specific partition. You cannot do transactions across multiple partitions, but inside one partition, it works fine. And it's a very cost-effective storage because 1 terabyte of data will cost you around $46 per month. But for cloud storage technologies, that's not that much. However, need to be aware that there is no real SLA on performance. It means that one query, one operation can take 2 seconds or 20 seconds, depending on conditions in Azure Data Center, and it's totally fine. It's okay, it should be expected. There are also multiple features that are common to storage account as a whole for all 4 service types, including blob and table storage. And these are redundancy options. There are quite a few of them. So we have locally redundant, which is data replicated to multiple machines inside one data center. And this feature is called availability set. There is a zone redundancy, which is about replicating data between machines in multiple separate data centers, which are located in one geographical region. There's also geo-redundant, which is about replicating the data across separate geographical regions, like different countries, for example. And there is like GZRS, so geo zone redundant, which is a combination of geo and zone, pretty much. There are also several data protection options like versioning on the files, soft deletes, snapshots. There's a change feed where you can track all the changes that happen to the files. There are a few access tiers which determine how much do you actually pay for the storage itself versus number of read-writes operations to that storage. So hot is for a data that is like frequently accessed. You pay quite a lot for a storage space, but not that much for the operations, while cool is for a data that is rarely used. The storage is cheaper, but the operations read-writes are more expensive. And archive even goes even further, where the data is super cheap, but you need to wait up to 4 hours to access it. So this is for some real data archiving. And there are also performance tiers, which is basically about determining if your data lives on a fast but expensive SSDs or on slower but cheaper HDDs, so spinning drives. Next up is Azure Data Lake. Azure Data Lake is an offering designed for a big data and analytic workloads. And as such, it can handle up to 5 petabytes of data, which is quite a lot. It is built on top of storage account, so it has most of the features we just discussed, like the redundancy, access, and performance tiers. This is Gen 2. Gen 1 of the data lake is built on top of with different technology, and it is already obsolete. So Gen 2 is the place to go for new projects. And the main difference to regular storage account here is a presence of real hierarchical file system with files and folders. So you have files, folders, the example operations that I discussed before are super fast because renaming a folder is just one transactional operation. That's it. You don't need to rename hundreds of files. And the same for listing and all that. And the other thing is that this file system is HDFS compatible, which works really well with most big data tools like Hadoop or Spark or the whole big data ecosystem. And there are also POSIX compatible permissions on files and folder, just like on Linux. The next offering I wanted to discuss is Azure SQL, which is basically a managed platform as a service database offering. And it's a subset of full on-premise SQL Server with some elements removed to achieve high availability, scalability, and performance. There are not that many differences from like programming perspective, so most of the SQL features are there. However, there is no CLR, so .NET assemblies, no XML data type support, no cross-database queries, distributed transactions. That's not there. And also the full text search capabilities are limited. There are, however, major differences on the infrastructure and tooling side. So there is no SSIS and SSRS. There's no change data capture, data quality services, master data services. You cannot simply attach a database from some location on the hard disk. And the backups are fully automated and you don't have that much control over it. And it's not like super easy to restore a backup in Azure SQL. There is one exception to all this, and it's called managed instance. So this is a type of offering where you get like almost full SQL server in a PaaS-like fashion. This offering is like somehow specialized and it's dedicated to migrations from on-premise systems. But for new systems for new cloud-based applications, Azure SQL is the way to go because of its like super performance and simplicity. And the other thing to mention about Azure SQL is that it's multi-tenant. So even though you get your own database, the infrastructure under the hood is shared with others. So there might be some impact on performance and there might be some compliance issues as discussed before. In terms of scaling, there are two major models for Azure SQL. The older one, it is DTU based, and DTU is a blended measure of CPU, memory, and I/O operations per second. And there are like three basic tiers, three major tiers for that model: basic, standard, and premium, with different characteristics, as you can see on the slide. There's newer model, which is virtual core based, where the number of virtual cores is the main driver. And there are following tiers. There's general purpose with between 2 and 80 cores and up to 1 terabyte of max database size. There's also business critical with similar characteristics, but with much better I/O operations per second and latency, and it's much more expensive. There are also two others. One is called Serverless, where you pay for the actual usage per second, and it's automatically paused when there is no load on a database. But there is a significant warm-up time when it comes back online, and it can scale up or down automatically. This particular offering is targeted at some scenarios where database is rarely used and you want to optimize costs. And there's also hyperscale, where the data is kept outside of DB instance on a storage account. And because of that, it scales really well, both vertically with number of cores per instance increasing, and horizontally with number of database instances increasing. And it can handle up to 100 terabytes of data, which is much more than other tiers. So the next offering I wanted to discuss is Azure Synapse Analytics, formerly called Azure SQL Data Warehouse. It just got a rebrand last fall, and it's a managed platform as a service data warehouse offering. It's a database that is optimized for analytics and online transactional processing workloads. This type of processing has some specific usage characteristics. Data is usually loaded in batches. Usually there are no single inserts or updates. Also, the queries return larger data sets. They are often pre-aggregated, pre-calculated, rather than single rows. And it usually operates on much larger data sets than regular databases, up to several terabytes, because it stores like integrated data from various systems and some historic data. And Azure Synapse implements a concept of multi-parallel processing, which is basically a distributed database, where there is one control node that coordinates work and several compute nodes that do the actual data processing. And the data is sharded into 60 distributions. And these 60 distributions can be processed by multiple compute nodes, depending on the scaling that is currently selected. The data is kept outside of compute nodes, and it's shared between them. And the number of, as I mentioned, number of compute nodes can be between 1 and 60, depending on like scaling configuration. In terms of capabilities, this is actually where Azure Synapse Analytics really shines. So if you use column store tables, there is no actual limit on the size. Still, if you use row store tables, traditional row store tables, you still have a limit of 240 terabytes, which is still much larger than all Azure SQL databases. There are two main ways of loading data into Azure Synapse. Traditional one, where the data is ingested via some ETL tool like SSIS through control node. This approach has limited scalability due to usage of that one common control node. And there's also Polybase, where each of compute nodes is able to mount storage account as a table and directly process a file from the storage account independently of other compute nodes. And this scales much better, and it's like super fast, super efficient. For scaling, concept of DWU is used, which is similar to Azure SQL, and it represents abstract normalized measure of performance. Blend of CPU, memory, and I/O operations per second. And it can be scaled between 100 and 30,000. However, you need to be aware of the cost though. DWU is the main driver for Azure Synapse. For instance, a data warehouse with 1000 DWU and 1 terabyte of storage will cost you $11,000 per month in total. And the cost of the storage here will be $250, and the rest will go to DWU. So you can imagine how expensive will be the 30,000 DWU units data warehouse, probably something around $500,000 per month. So that is why it is possible to pause Azure Synapse outside of business hours and only use it during business hours. And the cost will be applied only for that period of hours used, won't be applied for the post period. But still, even though Azure Synapse Analytics is like really expensive resource and it's targeted at specific analytics, business intelligence use cases. Next up, there's Azure CosmosDB, which is a platform as a service, NoSQL document database. And it has multiple API surfaces, which means it can be accessed in a multiple ways. There is SQL API, MongoDB API, Cassandra, Graph API, and table storage. And table storage is basically the same as in storage accounts, but this time it has some certain performance SLA. So it's like premium version of table storage. The whole idea is that it's easy to migrate systems from like MongoDB, Cassandra to CosmosDB. Theoretically, it should be all the client applications should work out of the box. And the most popular API is SQL, which operates on JSON files. It provides some basic SQL features like select, where, aggregates, grouping by, paging, sorting. However, some more advanced features like joins, common table expressions, apply, cross-apply operators, windowing functions are not there. And all the data, all properties of JSON documents stored are automatically indexed, so you can quickly and efficiently search for anything. And this can be adjusted through indexing policies, because sometimes it might be not the optimal way because it consumes space. CosmosDB uses a concept of data partitioning. Partitioning is mandatory here, but it enables great scalability. And there are two types of partitions. Logical partitions, which contain documents with the same partition key. They can be up to 20 gigabytes, and the number of them is not limited. So you can have thousands of these partitions. And there are also physical partitions, which are about allocating and spreading logical partitions on physical storage. And they are up to 50 gigabytes, and similarly, the number is also not limited. And as you can see on the diagram here, when you keep adding documents to particular partition, and when the logical partition is running out of space because of that, like for example, if I keep adding cities from Poland, logical partition will grow. When the containing logical physical partition goes out of space, it will automatically split into two partitions, and it will like balance the logical partitions they contain. So theoretically, it has unlimited scaling capabilities, assuming that the data is well and evenly partitioned. Really, partitioning is the key aspect here in CosmosDB. And to be honest, figuring out the right partitioning strategy and partitioning key is usually a challenge, because you need to consider multiple aspects. You need to have some insights into how your data is organized, what is like number of specific documents that have specific property values, so you can like estimate the number of partitions and their size. That's a tough, I would say, tough exercise. Yeah, and here are some notable Azure Cosmos DB features. You can configure consistency levels by specifying whether you are interested in consistent data reads at the cost of performance or vice versa. You can easily enable geo-distribution. It is as simple as clicking on icons on a map, this map here. I pulled it from Azure portal. You can click on particular blue points and easily distribute all your data to these regions. Obviously, you need to pay for that. Like if you have 3 regions, you pay 3 times as much. Once you enable it, your data will automatically be replicated. And you can also write the data in multiple regions, and this feature is called multi-master writes. So someone can do some write operations in, let's say, Los Angeles, and someone can do some write operation in New York, and the data will magically merge and will be replicated. Obviously, in such case, some conflicts are possible, and CosmosDB provides some options for defining how to resolve this conflict with conflict resolution policies. You can also write your own functions, stored procedures. Oh, sorry. Store procedures, triggers in JavaScript. There's also a really useful change tracking mechanism where CosmosDB can emit an event for each and every data change operation, for each and every insert, update, delete. And there's also time to leave feature where you can like expire the oldest documents and they will be automatically deleted. And you can also define unique keys on particular properties on a document that is stored. There are also several platform as a service data storage resources and offerings. Examples are managed Postgres, managed MySQL, managed MariaDB. MariaDB and SQL are almost the same. They originate from one code base. MariaDB is a fork of MySQL, as far as I'm concerned. There's also managed platform as a service Redis. There is Azure Search, which is similar to Elasticsearch. It's basically a search index. Azure Analysis Services, which is like cloud version of, I would say, all analysis services, so OLAP cubes, tabular models from SQL Server. And there's also Azure Data Explorer for like reviewing and analyzing logs on Azure platform. And this is it in terms of the content. And now we have some questions. Where does the files are physically stored in Blob? I mean, physically, it's obviously Azure infrastructure. All the virtual machines, all the Azure resources or their offerings, they run on the virtual machines. And these virtual machines, they have disks. And these disks are mapped to the physical hardware in Azure data centers. So there are like multiple racks of servers in Azure data centers. And these servers, they also contain hard disks. And this is where your files will physically be stored. What are hot, cool access tiers? So as I mentioned, hot access tier is for data that is frequently used, frequently read or written. And with this access tier, you pay quite a lot for the storage itself, but you don't pay that much for write-read operations. While in cool, it's actually the opposite. The storage is more expensive, less expensive, but the operations and accessing it is more expensive. You pay more for that. What are the differences between Azure Data Lake Gen 1 and Gen 2? So Gen 1, as I mentioned, it is based on different technology. It's not really HDFS compatible. It doesn't have all the nice features of storage account like replication, those access tiers, all that. And there are different technologies used for like working with the data on the data lake. There's a Azure resource called Azure Data Lake Analytics, and there's a USQL language, which is like combination of SQL and C#, and this is what you use to deal with the data in Data Lake Gen 1. While in Data 2 is more focused on open source big data technologies like Spark or Hadoop. Does Azure stores sort of images for each user and makes partitions of these images? But the blobs, it's a bit on that. Sorry, Vladimir, I didn't get that question. Maybe you can rephrase it. Where does Azure SQL is used in banking and capital markets? So I think this is a case-by-case basis. Generally speaking, banks and capital markets are not that eager to go to cloud. And if they do, they will be probably looking after infrastructure as a service offerings, or maybe this managed instance, because they are really after like security and compliance, and they won't accept that their data is mixed with other clients. So yeah, that's it. Is it useful in cloud computing in IoT? Yes, definitely. Some of these resources are used in IoT solutions. Typically, CosmosDB is often used for storing telemetry from devices. Sometimes it's raw telemetry, sometimes it's pre-aggregated telemetry, because it scales really well with this partitioning. The other potential destination is Azure Data Lake. So you store your telemetry on a data lake, and then you do some machine learning, some data science on it with big data tools like Spark.
There is a question in chat. I can read it. What about OneDrive and printing services in clouds? Is this a part of IaaS? From Paulina.
OneDrive is not really part of Azure platform, Azure Cloud. It's a software offering from Microsoft that is used for like file storage. Internally, it's also hosted on a cloud, and it uses these technologies, but it's more like consumer-oriented software. It's just like, for instance, mail service, Outlook Online, or Office 365. That's it. So it works on Azure indeed, but it's like consumer facing, and that's the difference. It's so-called software as a service. So one tier above platform as a service. CosmosDB supports, hi Andre, by the way, nice to see you. Now supports group by for SQL. Yes, that's true, a recent addition. How data security and integrity is addressed in data lake. So as I mentioned, in Gentoo, there are POSIX permissions, but there is also integration with Azure Active Directory. So you can grant access to particular files or folders to particular users or groups of users. And also there is a VNet integration. So even though these are platform as a service, you can still include them into virtual network, your own virtual network, which will separate them from outside world, from internet, with a quite new technology, which is called Azure Private Link. So it's just like plugging a disk to a network disk to your local network. Similarly, in Azure, you have storage account that can be connected to virtual network. How data is pulled up from structured and unstructured data in data lake. So if you use Spark, for instance, you can do that because it has support for both structured and unstructured data. You can program everything in Scala, on Python. So you can build a notebook that knows how to, for instance, deal with images, how to work with binary files, how to unzip things. It's like logic layer is transparent to the data lake. The data lake doesn't know anything about the data structures. It's just the storage.
One more question from chat. Does the configurable, so difficult word, consistency in CosmosDB also apply the availability altering, whatever it means?
To be honest, I don't see that question.
It's not in the Q&A, it's in chat. Somehow for Seni the Q&A doesn't work, so he sent the question to the chat.
Can I see it?
Yes, if you open the chat, this is this third question from the last one.
chat.
I can send it one more time here to chat. Unfortunately, as panelist, I can't post it in the Q&A, so...
oh, I see it here.
Yeah.
CosmosDB. Does the configurable consistency in CosmosDB also imply? I'm not sure what is availability altering. What do you mean by availability altering? So it doesn't impact overall availability of CosmosDB. It's just if you configure, let's say, eventual consistency, a document that you insert, other users will see it like maybe a minute after. That's it, not necessarily immediately. While if you configure strong consistency, the documents that you insert will be visible immediately to all other users, but the performance of the insert operation will be worse. It won't be as performant as eventual consistency. Okay. As platform as a service capability, so Azure can be useful in Smart Factory. Okay. Spark and Scala, or only Spark? Well, actually, Scala is a programming language that can be used on Spark. The other language is Python. And to be honest, I think C# is supported these days. So it is Scala via Spark. I think that was answered.
Another one from chat. I'll try to read it. Would it be possible to have multiple databases per region, like EMA, US, and APAC? And all these can have live replication?
So this is easy to achieve with CosmosDB, because it's as simple as like saying, hey, I want to have CosmosDB in all these 3 regions. With other technologies like SQL Server, it's not that simple. You can achieve it with replication, but you won't be able to write in all of these regions. You will be only able to read from this database in all 3 regions, but only write to it in 1 region, because that's how replication in SQL works. I don't know, do we have anything?
I believe the one for requirements for Azure learning were missed. Like, do you have anything?
Well,
in mind?
There are lots of materials online, lots of awesome courses on Udemy or Plural sites if you have access. And you can also get a free Azure subscription. I think it's free for 1 month. You just need to register and start using it. You will get some amount of dollars for your trial spent, and yeah, it's not an issue. There are also multiple flavors of Azure. It depends on your background. If you're a developer and if you're looking into developing some software, some systems with these offerings, that's one aspect. The other is maybe you are a DevOps engineer and you specialize in automation. You want to automate cloud deployments, cloud infrastructure. That's also something interesting. Maybe you are administrator or system engineer. There's also like room for you. So I would say that there are no specific requirements, but there are multiple aspects where you can look into and yeah, try to learn something, see what's there.
A couple of new questions in the Q&A. The first is, in what cases it is necessary to use cloud databases?
I would say if you want your system to be running in the cloud and leverage all the benefits of cloud, like availability, scaling, elasticity. If you want to have your system in cloud, then you need to use these offerings, or you can use infrastructure as a service and install your own software. Still, there are some hybrid scenarios where some of your workloads, some of your applications can access data on your on-premise databases that are not in the cloud, but in your data center or in your office. But for that, you need to have a VPN setup, or you need to have a Azure Express route, which is a carbon fiber connection. I can see how Azure SQL is different from MS SQL Server. I think I already discussed that during the presentation. So Azure SQL is a subset of full SQL Server. Lots of features are removed, like this, for instance, this change data capture, SSIS, SSRS, they're not there. So that better performance and availability than they should. Oh, I think I'm losing my voice. So
yeah, we are almost there. We have only 8 minutes during the end of the session. Well, let's, if there is a question that have been answered, pick up one, so we'll be just in timing. Because some questions we have in the list already have been answered, but I'm not sure which of them already have been answered. So could you please check one more time? And while you are checking, I would like to say to guys who collecting our keywords, now you can see one on your screen, which is generate. Wojciech hided it very nicely, so please notice that and keep it until our final session on Saturday. Yeah, so for now we have 6 webinars generate, which is almost a sentence. Next week, we not next week, but next days, we should find out what generate.
I think that is pretty much it. I don't see any other questions, so we can probably wrap this up. So.
Yeah, it means you covered everything. So thank you so much for your presentation. I launched a short survey as usual for our attendees to evaluate the session. I saw a lot of people asked about presentation. Of course, it will be shared within attendees or guys who attended at least like for a minute this webinar. I will send this presentation to you all, but not today, tomorrow. So thank you for joining. Wojciech, thank you for a really great presentation. It was full of interesting and useful details. Guys, thank you for being here the 3rd day, and see you on Thursday. See you tomorrow.
Thanks a lot.
Yeah,
thanks for listening to me. Hopefully you found this informative and helpful.
Probably yes. Okay, one more, just a couple of seconds more to fill out the survey, and I will end the meeting. Great, 100% people voted. Super duper. Thank you guys. Thank you so much, and have a nice evening, day, morning, whatever. See you tomorrow. Bye bye.